All right, so first thing we're going to talk about is wave interference and principle of superposition. All right, the first thing you need to realize about waves, all right, they're not like actual physical matter that interacts or affects each other. For instance, I have this hand here. If I slap it down, right, it's been affected by my other hand. Waves are more like, you can think of them like ghosts, okay? They don't actually interfere with each other. Okay, you'll have a wave going by to the left, you have a wave going to the right, and after they pass each other, there's no effect. Now, what happens in the middle is more of an optical illusion. They appear to affect each other. All right, so we have the crest of a wave here, we have the trough of a wave here, and so we gave values to them. This has a value of -3, right? This would be the resting point, right? This would be the trough. It's just a single pulse. This would be a crest with a value of +1, 1 being the displacement from the resting line to the crest, okay? And so after they pass each other, this will still have a value of +1, whereas this one will still have a value of -3. Where the principle of superposition comes in just means that they're taking up the same position, you superimpose them on top of each other. So for instance, if I have a value of +1, right, and a value of -3, okay, this is simple algebra. -3 plus 1, what it would actually look like is -2. Okay, but only while they occupy the exact same position in the medium. Again, when they're overlapped, they're superimposed on each other. Once they pass, okay, that goes away and they go back to being what they were before, +1 and -3. They really have no effect on each other. They only displace the medium. All right, so if we had +3 and -3, so +3 crest, -3 trough, they're single disturbances, right? They'd still look like that. But once they were superimposed upon each other, right, you don't see this. You wouldn't, I mean, like, that's not even possible to see a crest and a trough occupying the same place. So what would happen is we'd use the principle of superposition. They'd overlap. +3, -3 equals what? It equals 0. So that's what you would see. You'd see a crest and a trough coming towards each other, and once they take up the exact same space, you'd see nothing. It'd look like no disturbance. It would look like they canceled each other out, okay? But that's only while they occupy the same space. Once they move past each other, you would see the crest and the trough again, okay? That's all it is with wave interference. They don't actually interfere with each other. It's just an optical illusion. Okay, and the principle of superposition is nothing more than you algebraically figuring out, well, where would the wave disturbance be? Again, +3 -3 would equal 0. Okay, if we did +3 and +1, so let's say we had two crests that were coming towards each other. All right, obviously they wouldn't cancel each other out, okay, and you wouldn't see two waves, two distinct individual waves at the same time, so you'd have to superimpose them. So you'd have +3 +1, and what you would actually see would be the +4. Right? So it'd be an even bigger wave while they were on top of each other, but once they passed each other, you go back to the +3 and the +1 wave, and it's not like they hit each other and bounce off and go in opposite directions. They merely pass straight through each other. It's like two ghosts passing through each other.